Copper wire manufacturing is a precise industrial process used to produce high-quality electrical conductors.
At the factory level, this process follows strict steps to ensure purity, strength, and conductivity.
Molten copper is cast and hot-rolled into rods, then rapidly stretched through a series of dies at high velocity, finally wound onto industrial spools.
Copper is usually received in the form of copper cathodes, copper rods, or recycled copper scrap. All incoming copper material is weighed, recorded, and visually inspected for quality.
If recycled copper is used, it is first sorted and cleaned.
Clean copper ensures better conductivity and smoother wire production. The cleaned copper is transferred to a melting furnace, commonly an induction furnace.
The furnace temperature rises above 1080 degrees Celsius, which is the melting point of copper.
We have a spike in reactor 3.
Temperature is climbing fast.
Yes, but the consistency levels are holding steady. It should stabilize. All right, adjusting the flow rate now.
During melting, impurities float to the surface as slag. This slag is carefully removed to maintain copper purity. High-purity copper is essential for electrical wire manufacturing. Once the molten copper reaches the required purity, it is poured into a continuous casting machine.
These rods are rapidly cooled using water cooling systems to lock in strength and structure.
Any defective rods are removed and recycled back into the melting process. Before drawing, the rods are cleaned again and coated with a lubricant. This lubrication reduces friction during wire stretching.
Each die gradually reduces the diameter of the rod. As the copper passes through multiple dies, it becomes thinner and longer.
This process transforms thick copper rods into fine copper wire. After drawing, the wire becomes hard and brittle. To restore flexibility, the wire goes through an annealing furnace. Controlled heat treatment softens the copper, improves ductility, and enhances electrical conductivity. The wire is then cleaned to remove any remaining lubricant or oxidation. For electrical applications, insulation is applied to the copper wire. These machines check wire diameter, conductivity, tensile strength, and surface finish. Only wires that meet industrial standards move forward. Proper tension control ensures uniform winding without damage.